Welcome to this lesson, guys. So in this lesson, we want to look at our last example involving exponential equation. Okay, so this is the most complex one that you can have in exponential equation. So this is activity 3. Solve the following equations. So first of all, when you have equations involving this kind of problem, or let me write it out very well. 3 raised to power 2x minus 80, number 1. 3 raised to power 2x minus 80 times 3 raised to power x minus 81 equals to 0. So when you have this kind of equation, it normally leads to quadratic expression. So you kind of or use quadratic manipulation to solve. So what we're going to do is we are going to simplify the power. So 3 raised to power 2x can be written as 3 raised to power x raised to power 2. Okay, so we're going to let 3 raised to power x equals to a. Okay, so that 3 raised to power x squared will be equal to a squared, and then we can substitute and solve. Okay, so we're going to substitute this expression there and solve. Then we're going to have in this equation that a squared for the first one minus 80a minus 81 equals to 0. Okay. So we let 3 raised to power 2x equals to a squared, 3 raised to power x equals to a, so we have 80a. And then this is a quadratic equation, and we can solve by factorization. What two number can you multiply to get minus 81 and add to get minus 80? So the two number are simply what? Good. Plus 80 and minus 81, right? Minus 80 and plus 81. So minus 80 and plus 81. Minus 80 and plus 1. What two numbers can you multiply to get minus 81 and add to get minus 80? That's what we are looking for. Okay, remember, we've not gotten the two numbers. So let's find the factors of 81. 81, we know that if we do 9 times plus 9, we'll get 81, but 9 plus 9 will not give us the answer, right? Okay. Minus 81 multiplied by plus 1 will give us minus 81. Minus 81 plus 1 will give us minus 80. So we can use that one. So the answer is A minus 81, A plus 1 equals to 0. So A equals to 81 or A equals to minus 1. So now that we've gotten the value of A, you know our aim is to solve for x, not A. So we are going to be using the roots that we have to solve. So when A equals to 81, we have 3 raised to power x. 3 raised to power x equals to 81. So 3 raised to power x equals to 3 raised to power 4. So equate the base, x equals to 4. And also when A equals to minus 1, we have 3 raised to power x equals to minus 1. So since minus 1 is going to be undefined, there's nothing we can do here to get minus 1. So we're just going to simply say kind of no solution. Okay, no solution. So the only answer we have is x equals to 4 for this equation. Okay, and it is true because if you check, we're going to get the answer. You can simply check by substituting 4 in that equation. Let's quickly do a check. So 2 raised to power 2 times 4 minus 80 multiplied by 3 raised to power 4 minus 81. So let's see what we are going to have. 2 times 4 is 8. what is 3 raised to power 8? 2 times 4 is what? It is 8. So we can simplify. This is 3 raised to power 8 minus 80 times 3 raised to power 4. 81 is also 3 raised to power 4. So we can factor out 2 raised to power 4 here. So that is 2 raised to power 4 minus 80 minus 1. So this is 2 raised to power 4 into, this is 81 minus 81. 81 minus 81 will be 0. So 3 raised to power 4 times 0 equals to 0, which is equals to what we have on the right hand side. So we've shown that the left hand side equals to the right hand side, so it's correct. So this is how you solve this kind of problem. Let's take the next example together. P raised to power half raised to power 2. So we have number 2. P raised to power half raised to power 2 equals to 30 minus 13p half plus 36 equals to 0. So 2 will cancel 2 here. We have p raised to power 1. Okay, or let's not cancel, because if we cancel, we'll have to simplify this one, which will not make sense. So we just say let p raised to power half equals to a, so that p raised to power half raised to power 2 will be equals to a squared. Then we have that we substitute, we have a squared minus 13a plus 36 equals to 0. So we can solve. What two number can we multiply to get plus 36 and add to get minus 13? Let's think. So if we quickly sort that out, we are using factorization method. So factorize. So 36. We know that 12 times 3 will give us 36, right? But we can't have this to give us that. What about 6 times 4? 6 times 6 minus 6 times minus 6 give us 36, but we can't have it that. What about minus 9 times minus 4? So this will give us plus 36, and minus 9 plus minus 4 give us minus 13. So the answer is a minus 9 brackets a minus 4 equals to 0. So a equals to 9 or a equals to 4. So this is what we have, but we need to find the value of p, not a. So we're going to simplify, substitute again to find the value of p. So then we say when a equals to 9, so it then implies that p raised to power half equals to 9. Okay, square both sides. In order to cancel the half, we square both sides. Equals to 9 square. So this cancels this, and then we have p equals to 81. Also, when a equals to 4, we have p raised to power half equals to 4. Again, square both sides. Square both sides. Okay, equals to 4 raised to power 2. So p equals to 4 raised to power 2, which is 16. So therefore, the two values of p are, so therefore we have that p equals to 81 or p equals to 16. That's the final answer. So this is how you solve this kind of exponential equation. So in this lesson, we've looked at the various forms of exponential equation, from simple to intermediate and to complex. And then I believe you can solve any form of exponential equation now. Go to the exercises, take your activity,